I'm audible?
Yes, sir.
Yes, sir.
Okay. Let's recording get started, then we'll start. Okay. Okay. So good morning, all of you. Today we are going to learn basics of microprocessor. So whatever we are going to learn today will help you to learn 8086. Okay. It is not related to 8086, but if your concepts are clear, it will be helpful to you for learning 8086. Okay. So the first thing that we are going to learn is hex numbering system. Okay, I hope all of you know that we are normally using decimal numbering system, right? Computer only understand binary, so it only save everything in 0 and 1, so that is binary numbering system. Okay, and in 8086, whatever number we are going to use, that all numbers will be in hex. Okay, hello, am I audible?
Yes.
Okay, now thing is, we know that in decimal there are 0 to 9, total 10 digits. Yes, in
Yes, sir.
binary we'll have only 0 and 1, 2 digits. While in hex we are having 0 to 9 and A to F, total 16 digit. Yes.
Yes, sir.
Okay,
Yes,
so
sir.
we are very much comfortable with decimal numbering system. Then why we need hexadecimal numbering system? Why 8086 is using hex numbering system, not decimal? Why is it so? Question will be like this. Can someone tell me why is it so? You are familiar with decimal, then why in microprocessor we are having hexa number, not decimal number? Can you tell me?
No, sir.
Okay.
Sir,
Huh?
because decimal में से combination ओछा बनता है, hexadecimal में combination વધારે बनता है. In case you want
Very
to
good.
digits.
Very good. This is one of the reason. Right reason. That is correct. Thing is, a major reason is, suppose if I need to represent 0, I can represent using binary 0. Fine. If I'm having 0 and 1, I need only 1 bit. Fine. But if I need to represent 3, then I need 2 bits, 1 1. Yes.
Yes, sir.
If I need to represent 6, I need 3 digit. Yes.
Yes, sir.
110. Yes. Same way, if I need to represent 10, or suppose 9, which is a digit in decimal, I need 4 digit, 1001. Yes.
Yes, sir.
Because using 3 binary digit, you can maximum represent 8 different combinations. Yes.
Yes, sir.
In decimal numbering system, we are having total how many combinations? 10 different combinations available, 0 to 9. Yes.
Yes, sir.
So
Yes, sir.
3 bits of binary will not sufficient, so we compulsorily need to use 4 bit. Yes, to represent each number or each digit. Yes. Hello. समझाइए? What we have concluded,
सर बात बोलो सर.
to represent each digit of decimal numbering system independently, I need 4 binary bits compulsorily.
Yes, sir.
Yes, because using 3 binary bits, I can only represent 0 to 7. I can't represent 8, 9. So if I want to represent this, I need to use 4 binary bits like this, right?
Yes, sir.
Now, if I use 4 binary bits, in that case, how many combinations are possible using 4 binary bit? 0 0 0 0 0 0 0 1. Like how many combinations are possible? 1 1 1 1. Total 16 combinations are possible, right?
Yes, sir.
Yes.
Yes, sir.
Now, out of these 16 combinations, if I represent that thing for decimal numbering system, we are only going to use 10 combinations, 0 to 9. Yes.
Yes, sir.
What about other remaining 6 combinations? It is going to get wasted. Get it?
Yes, sir.
Another thing is, suppose I am doing decimal numbering system, I'm using decimal numbering system, but your machine is at the end going to use everything in binary, right? Because we know that machine is only understanding binary. So suppose if I do 8 plus 2 in decimal, okay, so it will give me the answer. What is the answer? 10, right? So 8 will be represented like this, 1 0 0 0. 2 will be represented like this, 0 0 1 0. Fine. And my answer, which is 10, as I said, for each digit you are using actually 4 combinations. Here the answer of this addition will be 1010, and we have not assigned anything to 1010. So this is a garbage value for our processor. So it will not understand because these six combinations are useless. समझ पड़ी?
हाँ सर.
So because of this reason, we can't use decimal numbering system in our computers. So that's why what they have done, they have used hexadecimal numbering system where all 16 combinations of binary bits are used to represent one of the number. Yes?
Yes sir.
So this is one of the reason because six combinations are getting wasted in decimal and it may create issue later on. In hex, we are having all 16 combinations possible. It will solve our problem. This is the advantage. Another advantage, as he said, suppose it is my decimal numbering system. I have 4 digits available with me. 4 digits. Okay. What is the maximum number that I can store using 4 digits in decimal? Maximum number that I can store in decimal using 4 digits. 9999. Yes?
Yes sir.
Okay. The same thing using 4 digits in hexadecimal and hexadecimal number system. Which number I can store? Maximum number? Hello? Which number I can store? No idea. F. Yes? Hello?
Yes sir.
Yes, sir.
This is approximately 10,000, while this is approximately 65,000. So same space, but using hexadecimal number, you can represent a bigger number, while using decimal numbering system, you can represent smaller number. So this is another reason why we are using hexadecimal number in our 8086. So concept is clear. If it is not clear, just make sure that in 8086, if I write anything like this, then this 88 is nothing but a hexadecimal numbering system. If H is written, it is hexadecimal numbering system. By chance, I forget to write down H, still it is hexadecimal numbering system. Clear?
Yes sir.
When we talk about 8086, the number represented are hexadecimal numbering system. Keep this in mind. Now, one more thing. If I need to convert this thing into binary, how to convert this is my hex number. So 1111. 4 number like digits for one hex number in binary, and A is 1010. This is how you can convert your hexa number into binary, right? So if I am having 2 digits in hex, that is equivalent to 8 bits in binary. Yes?
Yes, sir.
If I am having 6, I want to represent, this is my hex number, I want to represent in binary. What is the value? 0110. So this is my binary. So one hex digit is equal to 4 binary bit. Keep this in mind. That means 2 hex digit is equal to 8 bit. 3 hex digit is equal to
12.
12 bit. And if I am having 4 hex digit, that is equal to
16.
16 bit. That means 88 is how many bits? 2. 8 bits, right? That means this is my 1 byte number. If I am writing 8878, then this is my 2 byte. That is 16-bit number. Yes? Clear?
Yes, sir.
Okay. So 1 byte is equal to 8 bit, 2 bytes is equal to 16 bit. This is called byte also. This is called word also. Okay. Now you need to tell me, chalo, little bit of exam, and I want someone to be very fast. 56, how many bit number?
2.
Huh? 56. This is all numbers that we are talking about is in hex. So 56, how many bits number? Fast.
8.
8-bit number. Good. Very late. Very slow. 58, 7. This number is how many bit number?
12.
Good. 5, 5, 6, 7, 7. How many bit number?
16.
Good. 8. How many bit number?
4.
Good. 5, 9, 2. How many bit number?
12.
Very good. 1, 1, 2, 3. How many bit number?
16.
Good. So in future, this should be very clear in your mind. When I write two numbers, that is 8-bit number, 4-digit, 16-bit number, because if this thing is not clear, your future will be very difficult in MPI. So make this thing very clear in your mind. Clear?
Yes, sir.
That, so this part is clear. So first thing that we have discussed is why 8086 use hex numbering system and how to deal with hex numbering system. Okay, 1, 2. Convert this into binary fast. Anyone?
One one
Jaldi.
zero. 1100.
Wrong. When it is a hex number, for each digit, you require 4 binary bits 0001, 0010. This is the binary. Clear? Again, 56. Tell me binary fast.
0101
Yeah,
0110.
very slow. 87. Fast binary.
1000 011.
Very slow. हमारी writing speed कहता तो जोर में बोलो. चलो, still good. So this is how you can represent number. A12 represent in binary fast.
1010 0001
So very slow, very slow. I have already completed. It should be very fast, but it is 12-bit, right? We know that. So now this is clear.
Yes.
Hello. So make this thing very clear in your mind. When in 8086, whenever we are talking about numbers, it is hex and how to convert that hex into binary. 1 digit of hex is equal to 4 binary bit. Keep this in mind always. Fine?
Yes.
Yes.
Yes, sir.
Okay. The second thing that we are going to learn is power of 2. Okay. So now concentrate again. 2 raised to 0 is equal to 1. 2 raised to 1 is 2. 2 raised to 2 is 4. So jaldi bolo. 2 raised to 3 is 8. 2 raised to 4 is
16.
5 is 32. 2 raised to 6 is 64. 2 raised to 7 is
128.
jaldi bolo. 256. 2 raised to 9 is 512. And 2 raised to 10 is 1024. But this 1024 we'll call as 1K. Okay. So kilobyte is not 1000, it is 1024. But for simplicity, we represent like this. Okay. Done? Yes.
Yes, sir.
Okay. Now, suppose I need to find out 2 raised to 13. What is the value of 2 raised to 13? So how to do that? 2 raised to 3 into 2 raised to 10. 2 raised to 3 is 8 into 2 raised to 10 is K, 1K. So it is 8K. Get it? So 2 raised to 3 is 8 and because of 10 it is 8K. Get it? Hello?
Yes, sir.
2
Yes, sir.
raised to 17 is equal to 2 raised to 7 into 2 raised to 10. 2 raised to 7 is what? 128 into 1K is equal to 128K. Get it?
Yes, sir.
Yes, sir.
Same way, 2 raised to 20 is equal to 2 raised to 10 into 2 raised to 10 is equal to K into K is equal to M. So megabyte. 2 raised to 20 is equal to 1 megabyte. Clear?
Yes, sir.
Yes, sir.
2 raised to 30 is equal to 2 raised to 10 into 2 raised to 20. 2 raised to 10 is K into M. Kilobyte into megabyte is equal to gigabyte. So this is G, 1G. Done?
Yes, sir.
Yes, sir.
2 raised to 40 is equal to 2 raised to 20 into 2 raised to 20 is equal to M into M is equal to terabyte or G into K is equal to terabyte, whatever you want to prefer. Done?
Yes, sir.
Yes, sir.
Yes. So exam starts now. Let me check who will give me the answer first. 2 raised to 34. What is the answer? Fast. Memory location. 2 raised to 4 into 2 raised to 30. 2 raised to 4 is 16. 30 is equal to gigabyte. 16 gigabyte. Yes?
Yes, sir.
તો બોલો જલ્દી કેમ આટલા બધા ધીમા છો નેટ નું બંધ ન કરતા 48 46 ચલો 2 raised to 46 આન્સર જલ્દી 2 raised to 46 2 raised to 6 into 2 raised to 40 yes? Huh?
6 terabyte.
64 terabyte not 6 terabyte 2 raised to 6 is 64 yes
Yes, sir.
Yes, sir.
Again, chalo. Again test. 2 raised to 15. Answer fast. 32
32.
K because it is 10. Yes.
Yes, sir.
જરાક જોરમાં બોલો તમારા કરતા હું સ્પીડમાં આન્સર આપું નહીં ચાલે 22 ચલો જલ્દી 4 મેગાબાઇટ હા સ્પીડમાં કાઉન્ટ ફાસ્ટ 2 raised to 32 જલ્દી હાઉ મેની બાય
4 megabyte.
વેરી ગુડ ચલો કોઈ તો આન્સર આપ્યો લખવા પહેલા so this is power of 2 this is also very important when you are learning 8086 so આ બધું આટલી સ્પીડમાં થવું જોઈએ જેટલી સ્પીડમાં હમણાં થયું get it then only it will be very useful otherwise the people will solve the example in 2 minutes and you will take 20 minutes to solve the same example get it
Yes, sir.
Yes,
this
sir.
is clear very much clear
Yes, sir.
Yes, sir.
so we have covered two things hex number and power of 2 now third thing that we are going to learn is instruction cycle okay now why to learn instruction cycle any processor is doing only three things keep this thing in mind fetch decode and last is execute this is the work of any processor any bigger processor or smaller processor doing these three things only it may be a way of doing the same thing is different but they are doing these three things only basically fetch decode and execute so let's take one small example suppose I am having one processor which can do only 4 tasks plus minus multiplication and division okay hello are you there
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
okay, I am having 2 by cross 4 decoder here it is plus minus multiplication and division here we'll have two inputs here we'll have two inputs now in one more thing if this is my memory okay any memory location contains two things always as we have discussed in our last lecture when I talk about memory consider it as a RAM always so any memory you have it contains two things one is called address and one is called value on that address okay so suppose here it is 1010 so this is my address of memory 35 stored in this location this is 1011 40 is stored on this location clear any location in memory contains two things address and value okay hello
Yes, sir.
okay so suppose now and in your memory there are two things that can be there in your memory one is called program and one is called data if I stored movie it is called data if I stored program it is program right so suppose I am having a phone available WhatsApp is there then WhatsApp is my program and the chats in that WhatsApp are my data if I am having a movie watching app available then Netflix is my program and movies that you are seeing are the data your memory contains only two things always a program or a data clear
Yes, sir.
Sir.
so you can represent your what you can say date like everything available in memory into two parts program or data it depends on the requirement so suppose now I am making these things 00 means plus 01 means minus 10 means multiplication 11 means division now here is my actual memory for my processor where here it is 11101001 this is written so now this is my program written here in memory how processor will execute it so processor first come here and fetch the value so it will come to know that it is 11 yes
Yes, sir.
Yes, sir.
this is called fetching after this 11 your computer need to understand what this 11 means for computer everything is binary but what this 11 means for this program so this 11 is nothing but it is called opcode is nothing but operational code so CPU like your processor is already having this table available so what it will do it will go to this table and check out what this operation code is all about so 11 means division so whatever two number it is having what it will do it will give it to this decoder we know the work of decoder one line is selected so this divided is selected and that two number will get divided so that is my execution समझ पड़ी
Yes, sir.
Yes, sir.
So again,
હેલો
next,
સર
yes.
ફેચમાં ખબર ન પડી.
So suppose in my memory, these numbers are stored 11101001. I need to execute this program, right? This is my task. Everything will be in binary. That is clear in memory.
યસ સર.
Okay, so what your CPU will do? CPU will first fetch 11. So this is my fetching. Memory mathi 11 lesser. Done?
યસ સર.
What is this 11 is all about? This is opcode. So your CPU don't know what to do. So CPU then decode it. So decode કેવી રીતે કરશે? It will check the table. What is 11 means? Divide. Right? So I decode કરી દીધું કે મારે divide કરવાનું છે. Then it will give this instruction to actual CPU and ALU, arithmetic and logical unit. So what it will do? It will divide the two numbers, whatever available to it, and it execute the answer. So first it will fetch this instruction from memory, it will decode it, and then it will execute it. Get it?
યસ સર.
This is what happens for any processor. Now here we have used 2x4 decoder to do the same task. Actual machine will contain lots of decoders and like multiplexer and everything. It is a very complex circuit. This is just for the sake of example. I have taken this example. Get it? But in a way, it will do the same task. It will go to memory first, fetch the instruction. After fetching the instruction, decode the instruction based on opcode available. And once it decode the operation, it will execute it. Done?
Yes, sir.
So this is the basic work done by any processor. And these three things is called instruction cycle. Keep this in mind. If you know this thing, you can understand the architecture of 8086 well. In future also, if we deal with any external chip, you can understand how that chip will work. If you understand this thing. If you don't know this thing, it will be very difficult. Understand? Fetching the data from memory, decoding it, and then execute it. Okay?
Yes, sir.
Okay. So this is the third thing which I want to cover. And the last thing that we are going to discuss today is bus. All of you know what is bus is?
Yes, sir.
What? What is bus?
So you transfer information from one place to another place.
Very good. Bus will transfer data from one place to another place. It can be actual bus or a bus in a system, right? So now bus can be of three types. It can be an address bus, it can be a data bus, or it can be a control bus. Okay. Now how bus actually implemented in system? It is a single line. A single line which is attached with your transistor or any other circuit. Now, if you have studied transistor well, it is having VCC and ground. Yes. So if this line is connected with VCC, means 5 volt is attached with it, it is represented as 1. If this line is attached with ground, it will be represented as 0. Okay. Physically, all these things are so small that you can't even see. Get it? So don't worry. It is working like switch. If switch is on, it is 1. If switch is off, it is 0. It will be work like that. Get it?
Yes, sir.
Hello.
Yes, sir.
But that switch is so small that we are not able to see. What that mean? A single line can carry only 1 bit of data. Yes, because it at a time it can be on or off. Yes.
Yes, sir.
So if I want to transfer 8-bit data, I require 8 lines. Yes. These 8 lines together is called a bus. Get it? Bus is not a single line. Bus is a combination of lines. Done?
Yes, sir.
This concept is clear?
Yes, sir.
One line can carry 1 bit of data, 2 bits can 2 bit of data. So if I want 8-bit data, I need 8 lines, and together it is a single bus. Fine?
Yes, sir.
Yes, sir.
Okay, now very good. So now we'll study how address bus, data bus, and control bus will work. So for that, we'll understand read and write operation. Okay, how read and write operation perform in computer. So suppose this is my memory. As usual, we know that here 30 is written. This is 10101011. On this 30, I want to write down 40. This is what I want to do. Okay, so this is my MUP. MUP is microprocessor, right?
Yes, sir.
So how flow will be go, like first thing is address bus will go and give us the address 1010. This is the work of address bus. So address bus will carry 1010. So we'll get to know that કે મારા 30 ઉપર જઈને કંઈ ચેન્જ કરવાનું છે. Done? શું કરવાનું છે તે we don't know. Our microprocessor still don't know that what it want to do. It just know that on address 1010 we need to do something. Done? So 1010 will come in address bus. Clear? Hello?
Yes, sir.
Okay, next. As I want to write 40, so my data bus will now carry 40 because microprocessor know in advance that 40 will be there. So 40 will be put on data bus. Okay. Now, next is my control bus will tell my memory as well as my microprocessor that you need to write. So now my microprocessor will write this 40 onto this location. This is how your three buses will help and work. Get it? So the flow will be first address bus will be used. It will carry the data like address, what you want to do with this particular address. Then you will send the data because it is available to you because you want to write something. And then control signal will give the signal that write. Now, in case of reading, suppose this is my memory. This is my 1010, 30 is stored here. I want to write this 30. So same procedure. First address bus will carry 1010, right? No issue. But now I don't have any data. So data bus is not used. So now next is control bus is used and it will tell me that I want to read something. So once I get to know that I need to read something and I know the address, data bus will be used and 30 will be given on this data bus. So the flow is little bit get changed. Here address bus comes first, then control bus comes and then data bus comes. Understand?
Yes, sir.
Sir,
Yeah. Okay. So, હા બોલો.
સર તમે કીધું કે જે બી બસીસ હોય તે મતલબ કોમ્બિનેશન ઓફ પેલી લાઇન્સ હોય.
Lines હોય, હા.
તો સર હવે આમાં મિનિમમ કેટલી લાઇન્સ હોય? આ ઉપર બી તમે જે 1010 લીધો તો મતલબ 4 લાઇન તો જોઈએ, મતલબ 4
It
બીટ.
no, it depends on processor. Suppose our 8086 is 16-bit processor. So our data bus is having 16 lines while our address bus is having 20 lines in our 8086. That will come in the architecture soon. Okay. Now current generation, all the processors, if you study, we are using 64-bit processor, right?
યસ સર.
આપણા બધા સોફ્ટવેર 64 બીટના છે. So in our case, all our data bus, full data bus is of 64 lines. Get it?
હા હા સર.
So
જેટલી બી બસ અલગ અલગ હોય, ડેટા બસ, એડ્રેસ બસ, તો બધાની લાઇન્સ બી અલગ અલગ હોય.
અલગ લાઈન હોય. હા, એટલે તમે મધરબોર્ડ જોશો ને એમાં તમે પેલી ગોલ્ડન કલરની લાઈન દેખાય, that is a line. Again, that line is big, but એની અંદર કદાચ multiple lines પણ હોય. We are not able to see it physically. Get
Okay.
it?
હા સર.
Yes. So it depends on the processor that you are using, that how many lines your processor buses will carry. Done?
હા સર.
Yes,
So this is all about address bus, data bus, and control bus. Now, control bus is not only about read and write. There are so many other signals are possible that we are going to learn when we'll cover 8086 and some interfacing in detail later on. Fine?
ઓકે સર.
So this is it for today's lecture. Again, just for the sake of revision, we'll let you know what we have covered. One, we have covered why we are going to use hex numbering system, how it will work. Next, power of 2. You need to understand power of 2 because it will be very useful to understand future sums and interfacing of 8086. Third, we have covered instruction cycle where it will do fetch, decode and execute. And fourth thing that we have studied is bus. There are three sort of bus: address bus, data bus and
કંટ્રોલ.
control bus. Done?
યસ સર.
So
Yes.
this is it for today's session. Okay. Okay. Let me stop recording first.